Well, here's where I wanted to show you the tremendous power of polar coordinates. You see, in polar coordinates, how would I write I? I is what? Its magnitude is 1. See, it's the points 0, 1 in the Argonne diagram. Its magnitude is 1, and its argument is pi over 2. By the way, again, I'm in this trouble with multiple angles. You see, it's not only pi over 2. It could be 5 pi over 2, 9 pi over 2, etc. Every time I go through 2 pi, I come back to the same point. I'm going to mention that in a moment. But the idea is, look at, this is what I want. This is I, and I want the 6th root of I. Let's assume that the answer can be written in polar coordinates. If I write it in polar coordinates, the answer is r comma theta. All I've got to do now is solve for r and theta, and I claim, believe it or not, that that's trivial. Namely, given this, I raise both sides to the 6th power. If I do that, I wind up here with I, which just, to get this all on one line, I just repeat this. This is 1 comma pi over 2 in polar coordinates. And this is r comma theta to the 6th power. But the beauty of multiplication in polar coordinates is that r comma theta to the 6th power is r to the 6th comma 6 theta. The magnitude is the, see, in other words, you multiply the magnitudes and you add the angles. Therefore, what this tells me is, remember, r must be real. There is only one real number which, when raised to the 6th power, is 1. And that's 1 itself. See, the nth root, the nth root of any positive number has exactly one real solution. That's why we can always find the r. In this case, I picked a simple example where r turns out to be 1. See, minus 1 also raised to the 6th power is 1, but that doesn't count because we agreed that r had to be positive. R was measuring the magnitude of the complex number, so r must be 1 by virtue of the fact that r is greater than or equal to 0. That eliminates minus 1. Now, 6 theta can either be pi over 2 or 5 pi over 2, etc. The important point being that we now tack on the 2 pi k, because notice that as this changes by 360 degrees, theta only changes by 60 degrees, because 6 theta is changing by 360. Therefore, you see, we're going to get a whole bunch of theta values that work this way. And again, I'll explain this in more detail as we go through the exercises on this unit. But the idea is what? If I keep tacking on multiples of 2 pi, what I'm saying is r must be 1, and theta is what? It's pi over 12 plus what? 2 pi k over 6, pi over 3k, 60 degrees. In other words, I essentially, in terms of angles, tack on 60-degree increments here. To make a long story short, r must be 1, but theta could either be pi over 12, 5 pi over 12, 9 pi over 12, 13 pi over 12. See, I'm adding on 4 pi over 12 each time, pi over 3, 60 degrees in degree measure. 17 pi over 12, 21 pi over 12. The next one would be 25 pi over 12, but I hope you can see that that's the same as, position-wise, 1 comma pi over 12 gives me the same thing as 1 comma 25 pi over 12, but all 6 of these angles give me different positions. Just by way of illustration, pi over 12 turns out to be 15 degrees.